Hi, welcome to my classroom. So today we are on the last section of chapter 2, 2.5 measures of position. So we're basically talking about within a data set where each of the data points actually are in relation to everything else. So we've got a few vocabulary words to describe this. The first one is fractals. So when I hear fractals, I think of this Frozen song, Let It Go, because I think it's like swirling fractals all around. Da 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 da. Okay, that's it. Okay, so what fractals actually are, it's when you have numbers that divide an ordered data set into equal parts. So first off, you have to have your data set in order first, so smallest to biggest or whatever. But we're basically trying to split up our data set into equal parts. And so the most common ways that we split this up are either called quartiles or percentiles. So quartiles, like the word says, like quarters, you're splitting it up into 4 equal parts so that we can see like what's in the first quartile, what's in the second quartile, so that we can see, you know, what percent is below you is kind of how I think about it. So like the first quartile would be like the first quarter of your numbers in the data set. So the smallest 25%, because you know, like a quarter is 25 cents. So the smallest 25% of your data set would be considered the first quartile. The second quartile would be like everything from the 25% point to the 50% point. So we actually have a name for this, Q1, to stand for the first quartile. The Q1 is going to be a number within our data set where 25% of the data is below it. So Q1 is actually the number like right above it. So the second quartile refers to the data point that has 50% of the data below it. We've talked about this before. If you have 15% of the data below you, that means 50% also has to be above you, which means you're right in the middle. So the second quartile, Q2, is also called the median, because remember, to find the median, you would put everything in order and then find the middle number. That's all the second quartile is. And lastly, the third quartile just means that whatever number Q3 is, means that there are 75% of the data below whatever number our Q3 is. So let's say we had some data set and we were trying to find Q1, Q2, Q3. So first we have to put all our numbers in order from smallest to biggest. Okay. So I just put all my numbers in order in the calculator. And if you have a calculator, you actually don't even need this step, because if you remember, when you do 1var stats in your calculator, it'll find you the mean, the standard deviation, and if you scroll down, it tells you Q1, the median, and Q3. So you are done. If you're doing this by hand, then we are going through and looking for that middle number. So what I do is just I start at the ends, count towards the middle, and that'll give me the median. Remember, if you have like 2 numbers in the middle, you add them, divide by 2, and then that'll be your median. So here, as I counted towards the middle, 18 ended up being my middle number. So that is my median, aka Q2. Okay. So if we're talking about Q1 and Q3, since Q1 and Q3 are like, you know, 25% below and 75% below, that really means from the smallest number up to the median, Q1 should be right in the middle of that. And then from the median to the maximum, Q3 should be right in the middle of that. So what I'm going to do is, starting from my smallest number up until, not the median itself, so we never include the median, but up until the number, up until the median, I'm going to use those numbers to count towards the middle. When I do that, I actually get just 10 as the number that's in the very middle between where my 2 arrows are. So that will be my Q1. And then I'm going to do the same thing on the other side of the median. So between the 18 and the 104, the middle number ends up being 31 when I count towards the middle again. So that's Q3. I want to do another example where we have a different amount of numbers. So this time, to find the median, I'm going to count towards the middle. And this time, both 17 and 18 are in the middle, which means I'm going to add and divide by 2 to get the median, or Q2. that's going to give me 17.5. So if 17.5 is my median, now when I go to find my Q1 and Q3, I'm going to end up using 17 and 6 as like my endpoints where I start counting towards the middle from there. So this time counting towards the middle, I end up with both 8 and 10 being in the middle. So then again, I'm going to add and divide by 2 to get a Q1 of 9. I'm going to do the same thing to the other side. So because 17.5 was the median, again, I don't use the median itself to count towards the middle, but it'll be the number right next to it, so the 18 up until the 54. So the middle number ends up being between the 19 and the 20. So adding and dividing by 2, I'm going to get Q3 of 19.5. Okay, once you have those numbers, those are like our most important things that'll tell us position numbers within a data set. We can also talk about spread within a data set using these numbers. This is called the interquartile range. So you've heard of range before, where you just take the biggest number minus the smallest. Interquartile range is when you take Q3 and you subtract Q1. The reason why we sometimes like to use the interquartile range is because this will tell us how wide or like how far apart the middle amount of data is, because between Q3 and Q1 there's 50% of the data there, because Q1 has 25% below it and 75% above it. Q3 has 75% below it, 25% above it, with the median right in the middle. So Q3 minus Q1 tells us the distance between the middle 50% of the data. This is also good because let's say we had some numbers in our data set that were really far away from the rest. So outliers is our word for that. So like our original data set up here, this first example that we did, we had this really big number of 104. It's way different than the rest of my numbers here. And so when you have an outlier like that, that would affect the rest of your data when you calculate, like, let's say the mean, the standard deviation, but the median is not affected. And the interquartile range also wouldn't get affected because that outlier wouldn't even get counted towards it. And so that's why sometimes we like to use the interquartile range instead of, let's say, standard deviation to talk about spread. And so as we look at a data set, we like to, analyze it using numbers, so our median, our Q1, Q3 interquartile range, but we also want to look at it visually so we can make a graph for it. The graph that we usually make to talk about our Q1, Q3 median numbers is called a box plot. You might have heard of it as a box and whisker plot before, but box plot is, easier to say. So to make it, you just need to set up an x-axis, and of course we're always going to label our x-axis with whatever your data set stands for. And then we're just going to look at the numbers that we have. I'm going to use our first data set that we had, where we had numbers from 6 all the way to 104. So I'm probably going to go by tens on my x-axis, just because 104 is pretty high up. And then once we have everything set up, then we really just need 5 numbers to go on our graph. It's real easy to do. We start with our smallest number, which was 6. So I'm just going to draw a line above where 6 would be. Then Q1 is the next number that we want. So Q1 is 10, which is going to be right above the 10, and then I can just draw a line there. Our next number is the median, and for that data set it was 18, so that would be here-ish. Q3 is the next number, which was 31. And then our maximum number was 104, and that's the 5 numbers that we need. So it's the min, Q1, the median, Q3, and the max. Sometimes we like to call those 5 numbers our 5-number summary, which is really obvious as a name, but whatever. Okay, once you have your 5 lines, around the middle 3, so from Q1 to Q3, we draw a box around it. Thus the name box plot. And then with the min and the max, we draw lines going up to those values for the whiskers. So if you imagine like a box in the middle, whiskers on the sides, that's why it's called a box and whisker plot. But this basically shows you how spread out your numbers are in the data set, especially now if you see like we have this huge whisker on the right side over here. This just means that we have a lot fewer numbers on this side of the graph. So if you have a long whisker like this actually tells you the direction that it's skewed. Because if we don't have a lot of numbers over here, then that means if you were to make a histogram or something, you would have much shorter bars there. So this graph would be skewed right because we have a long whisker on the right side of our box plot. So if the long whisker was on the other side, then it would be skewed left. Okay, so we talked a whole bunch about quartiles up till now. I also want to talk about percentiles. Percentiles are basically, since fractiles are something where you split it up into even amounts, percentiles means we split by 100. Quartiles you split by 4. Percentiles, like a percent, you split by 100. Percentiles are mostly used like on transcripts because it'll show you like your class rank and also like what percentile you are. So this tells you what percent you're doing better than. So if you were the 90th percentile in your class, that means you're doing better than 90% of the students, of the seniors at your school, which is great. So the higher the percentile you are, the better. So with a percentile, okay. So for example, if a number is the Q3 in a data set, what percentile would it be? So Q3, we said there should be 75% of the data below it. So 75% of the data below it would be 75th percentile. And then if you think back to the ogives that we made back in the beginning of this chapter, so that was one of those 4 graphs that we did in section 1. The ogive was the one where we used the cumulative frequency. Well, if you use cumulative relative frequency instead, use percentages instead of just the counts of how many were in each bar, that would also be an ogive. And so if we read an ogive, we can actually use the y-axis as the percentiles when you use cumulative relative frequency. And so if the question asks what test score represents the 62nd percentile, we could look at our ogive, and since they're asking about a 62nd percentile here, then we can estimate 62% to be right here-ish on the graph. So when you read it, then you can see wherever that 62 percentile meets the graph, that'll also match up with the score. So it looks like about, hard to read, maybe like 1600 or something. And this is also kind of an older example because this is back in the SAT was based out of 2,400 points instead of 1,600. But yeah, so that's how we use percentiles. That's how we read an ogive with percentiles. The last thing I want to talk about in this section is the standard score. So for a standard score, we're basically trying to compare different data sets no matter what kind of unit of measurement the data is talking about. So if we're measuring like heights or something in inches, in feet, in meters, you know, whatever, versus measuring weights, anything like that, whatever unit of measurement the data is talking about, we want to actually have a way to compare no matter what type of data it is. So that's why it's kind of like the standard. It's a standard score. And so we basically use the number of standard deviations away from the mean that a data point is, and that's how we're comparing the data points to each other. And we kind of talked about this already when we couple sections ago, or no, last section, when we talked about the empirical rule, or Chebyshev's, because we would say this number is 2 standard deviations away from the mean, or 3 standard deviations away from the mean. And so that was kind of almost talking about the standard score. Just now it doesn't have to be an exact number of standard deviations. We can say like actually 2.5 standard deviations away from the mean, or something like that, or 2.28 standard deviations away from the mean. So in order to find that standard score, there is a formula for it. We also call the standard score a z-score because it's easier to say. So we use the letter z equals, so we're going to take our data value, and it's usually like whatever they're asking about in the problem, and we're going to subtract the mean from that, and then we're going to divide by the standard deviation, and that'll give us our standard score, or the z-score. In symbols, sometimes you'll see it look like this: x minus mu over sigma. And so we've kind of talked about these symbols already. X is just going to stand for the data value. Like, what is the question asking for? That'll be your x value, because then we can like solve for x and things like that. Mu is this weird like M looking symbol. Mu looks like an M, looks like a U. We read it as mu. It just stands for the mean. And then on the bottom, sigma is like the O with a hat. We've seen it in our calculator. It just stands for standard deviation. And so that's how the formula we would use to find a z-score. If we do an example, we've got SpongeBob can lift 2 pounds in weights before his pants rip. So if you remember this episode, it's a good one. There's a great song with it. But the average weight Bikini Bottom residents can lift when they work out at the gym at Goo Lagoon is 11.5 pounds. So obviously SpongeBob is not the strongest. And then there's a standard deviation of 3.2 pounds. What is SpongeBob's standardized score, or his z-score? So SpongeBob, his score was 2 pounds. So that's going to be our x value because we're asking about his specific z-score. And then the mean they told us was on average 11.5 pounds. And then we're going to divide by the standard deviation of 3.2. When we do that, we end up with negative 2.968 something something something, but with our z-scores, we're always going to round to 2 decimal places. So I'll show you guys why later, but 2 decimal places, meaning our 3rd decimal place was higher than 5, so this is going to be rounded to negative 2.97. And that's it for this section. So thanks for watching. That's the end of the chapter. Bye.